In this video, we're going to look at authoring 2D levels in isometric perspective using Unity's Tilemap tools. We've created a demo project with some example sprites and a pair of characters for you to explore these tools with. In another video, we walk through how to set up the character controller for our witch character and play her animations. And you'll find a link to that, as well as a link to download the example files in the description below. If we enter play mode, we can see that we have a flat level and a character which can walk around in it. Let's learn how to add an elevated area to our level and also how to set up collisions. In creating this elevated area, we want to control what areas of our level are passable and impassable. For example, where there are steps which lead to one area to another. We can achieve this by using one isometric tile map for the part of the level which you see here already, and now we will enable our second raise level 1 game object in the hierarchy, which contains a second tile map on which we will draw our elevated platform and steps. Having our elevated tiles on a second tile map allows us to ensure that they sort correctly on top of the other elements of our level. We achieve this by adjusting the order and layer property of the tilemap renderer to make sure that they are rendered in front of the ground. The first thing we need to do is to set our active tilemap layer to raise level 1. With the brush tool selected, we select the tile we want to draw. We can then paint our raised area onto the level by clicking on the scene view to place the selected tile. We repeat this process with all the tiles we would like to draw. Now that we have our platform drawn, we need to author the collision geometry. We are using a third tile map to define the level colliders. Authoring colliders in an isometric perspective is different from other types of 2D perspectives. What areas the player can walk in are more ambiguous, and so it's helpful to have a level designer specify them by hand. An example of this is we want our player to be able to walk on the stairs, but not walk directly from the lower level onto the platform. We've created a third tile map object already, which we will use to author our collision data on. We've tinted this tile map with a pink color by using a custom material in the tilemap renderer's material field in order to make it more visible. We've provided within the tile set a number of sprites which are designed for authoring isometric collider shapes. By selecting the collision layer in the tilemap palette, we can paint directly onto the collision layer. Let's draw in shapes to make it so our player cannot walk directly onto the raised area, but instead must walk up using the stairs. We've added a tilemap collider component and a composite collider 2D component. These will automatically generate colliders based on the shapes drawn in this tile map and merge them together into a single composite collider. This allows us to have our player register collisions with the shapes defined by our level designer in this collider tile map. We've also decorated the level with objects on top of the tile map. We've created a few tree prefabs in our prefab folder and added them to the example scene under the decorations game object. We can see that these trees have a sprite renderer component as well as a child circle collider 2D component to define the collision geometry. We can easily reposition and add more trees as we please, and the player will correctly collide with the trunk of the tree at its bottom, but be allowed to pass behind the leaves at its top. To correctly sort the player and the decorations, we use the transparency sort mode, which you can access by choosing Edit, Project Settings, Graphics. We changed the transparency sort mode to Custom Axis and changed the Y value to 1. This tells the camera to sort transparent objects, such as our sprites, on top of each other based on the Y value specified in their transform component. Now we can see that the player will correctly walk in front of and behind the tree. We've also changed the pivot of the sprite using the sprite editor on the tree sprite and dragged the pivot to the trunk. This is important because the pivot defines the point at which the trunk is sorted in front of or behind overlapping sprites. If you like to experiment with these features yourself, we have provided this project complete with all artwork, example scenes, and scripts for you to download at the link below in the description. We look forward to seeing what cool stuff you create with it. Thanks for watching.